Welcome to the third and final section of Chapter M, chapter on matrices. This guy is all about something called Cramer's rule. And Cramer's rule is yet another way to solve systems of equations. So if you look in this blue box, it mentions the graphing method, which we have done in Chapter 2. Graph two lines, see where they cross. Substitution and elimination methods, I hope you are familiar with. And then we have a new guy. This guy's called Cramer's rule. So yet another way to solve a system of equations. So if you look at problem number 1, we've got an x missing, we've got a y missing. If we want to find them both, system of equations. So in all honesty, it would be a little easier to do this problem probably with one of those other methods. I would probably use the elimination method. But Cramer's rule is really cool if you know how to operate a graphing calculator. So if you knew how to enter matrices into a graphing calculator, you could literally hit the determinant button and you would get to the answer awful darn fast. If you have more than 2 equations, which we are going to look at an example of, then Cramer's rule does come in super handy. So we are going to show you by hand. Unfortunately, can't show you how to do it on the graphing calculator, how to do this. So here we go. First thing to point out, you want to have some equations that are in standard form. And if you recall, standard form means the x's and the y's have to be on the same side. So if you look at our 2 equations right here, both the x's and the y's are on the same side. The signs wouldn't matter. Standard form, you're supposed to have the x term be positive. It wouldn't really matter. You could have it negative. It works the same way. So it looks like there's a lot to the directions here, but it's just a matter of setting up some matrices. So if we're doing 2 equations, which in this case we are, we want to make some 2x2 matrices. If we were doing 3 equations at a time, we would be making 3x3 matrices. 4 equations, 4x4, and so on and so forth. So it can get kind of extreme, but again, if you had a graphing calculator, these are actually pretty darn easy. So I'll make 3 matrices. I'm going to call one x, as in I want to find the x answer. I'm going to call one y, as in I want to find the y answer. I'm going to call one d, and d stands for divide. So we'll do the 3 matrices, and then we'll show you how what to do with them afterwards to find the final answers. So I want determinants. Remember, this is the symbol for finding a determinant. And it's going to sound kind of weird, but if you want to find the x answer, you leave the x numbers out. So in place of the x's, in place of the 5 and the 2, I'm going to put the 13s, the answers that were on the end. And then I keep the y's. So the y's, I have a 7y, and I have a negative 5y. And I keep those. And we just need to find the determinant. We'll do that here momentarily. So for my y matrix, what I would do is I would keep the x's this time. So I would keep that 5 and that 2. I would leave the y numbers out, and in their place, I would put the 13s. So again, it sounds kind of weird, but it works out. In the divisor matrix, I would use the other combination. So this time, since I'm not looking for x, I leave the x. Since I'm not looking for y, I leave the y's. And you would leave the 13s off. So in other words, it's really every combination of the 4 numbers that you can use. So then we go ahead and we find the determinants. So I'm going to do that down here, or off to the side so you can see it. So for the x determinant, hopefully you remember how determinants go. You take the right-facing diagonal, which in this case would be the 13, times that negative 5 in the corner, and subtract the left diagonal. So the left diagonal would go the 7. To the left would be the 13. It's in that bottom left corner. And we just do the math. So multiply those first 2 together, you get negative 65. Multiply the second 2 together, you get 91. Combine those, and I get negative 156. Now, that's not the actual x answer, but we will use it momentarily to get the x answer. So bear with me, and we will do the determinant for y. So the y, right diagonal, would be the 5 times the 13 in the bottom right corner, minus, well, what's in the left-facing diagonal? That'd be the 13 in the upper right times the 2 in the lower left. And hopefully you watched some videos from section 2 and you would remember this, or you did well in section 2. Times these guys together, I get a 65 minus a 26 which gives me 39. So the determinant for the y is 39. So why the d? Well, you're going to see why here in a second. Let's go ahead and figure it out first. Again, right diagonals, 5 and negative 5, minus, sorry, I said that, yeah, that's right, right diagonal, times the left diagonal, which would be the 7 and the 2. And I got negative 25 minus 14 for a total of negative 39. So that is my third determinant. All right, now, again, these are not the answers yet. There's one more step to do, which is fairly easy. You just have to remember it. So if I want to know what the x-coordinate is for this system of equations, I take my x answer and divide it by that third matrix. Well, the x answer was negative 156. The third matrix, or the divide by matrix, was negative 39. Two negatives would make a positive. If we divide those guys, we get 4. The y coordinate would be to take the y matrix and divide them by that third matrix. So the answer we got for the y was positive 39. Again, the answer we got for d was negative 39. That equals negative 1. So if you had graphed these two guys, you would have seen that they crossed at 4, comma, negative 1. If you had done substitution or elimination methods, you would have got 4 and negative 1. So Cramer's rule, kind of cool. It's a little lengthy, but again, if you knew how to enter these on a graphing calculator, it would be so easy. All right, for the second problem, I don't know that I'm going to have time to do the entire problem, but I'm going to show you how to set it up. So as long as you remember how to do the diagonal thing with the determinants and have a calculator handy, it's actually not that bad. So again, I have two equations. So I want to use 2 by 2 matrices, but I want to also make that third matrix, which I'm going to divide with. So here's how it goes. So that's understood to be a 1x up there, and I have a 2x, but I don't use them. So the letter you're looking for is the one you leave out. I know it sounds weird. In its place, I put the guys on the end, the 1 and the 24. Since I'm not looking for the y, I actually use the y numbers. So for the y, I'm going to tell you what, I'm going to do these first. I want to leave the y's off. So I put the 1 and the 1, I put the 1 and the 24 in place of the y's. I would keep that 1x, and I would keep that 2. So for the guy I'm going to divide by, so this time I want to leave off the 1 and the 24. So it's the third combination, the third possibility. So I'm not trying to find the x's, so I leave or keep the 1 and the 2. I'm not trying to find the y's, so I leave the negative 4 and the 3. And there's my 3 matrices. So again, I'm not going to have time to go all the way through this, but real quick, one more time, I will just point out, here's how we find a determinant. We go right diagonal, 1 and 3, minus left diagonal, which would be negative 4 times 24. And you could obviously pick up a calculator to figure that out. But again, this is all mathematical computation with numbers, right? Easily done with a calculator. We get this answer, we get this answer. But here's the important thing to remember, which is what I will leave you with. Once you get those answers, you're not quite done. If you want the x-coordinate, you take whatever your x determinant was and divide it by that third guy. If you want to know what the y-coordinate was, you take whatever the determinant was for the y matrix and also divide it by d, and you got your answers. So again, kind of lengthy, but it's kind of a cool process. So if you would like to see how a 3-equation Cramer's rule is done, then watch video number 2. So as far as video number 1, thanks for watching.